Welcome to my most amazing PowerPoint ever. Sorry you can't see this in the classroom, but I'm going to show you here. This was created using photographs of actual pieces of paper and actual cubes. This is just a square face of a cube in perspective. In one-point perspective is just a square. That's all there is to it. The picture plane we should imagine as a piece of glass that we're looking through at the scene. Right now, since you're looking at this on a screen, you can think of the picture plane as the monitor of your computer or laptop. If you ask yourself whether this square, if we were looking through a piece of glass into another world, was parallel to the picture plane, the answer would be yes. Lines that go away from you on the floor in one-point perspective on a grid are called orthogonals. And if we take any pair of orthogonals, any two, it doesn't matter which ones, where they meet is going to be the vanishing point. There it is. And once we've found the vanishing point, we can use it to create other orthogonals. Notice that you can also use a vanishing point, as we did in the project we're working on now, to create a grid on the floor. It works both ways. So, using this vanishing point, and this is where some of you are having trouble, we can create any other line that's going away from us, like both of those. And this is that extruded shape I was talking about, the shape that just goes on forever. And the job, of course, now, if we're going to draw a cube, is just to cut this off. So all we do to cut a shape off is we count. It's just simple counting. 1, 2. And that's where, oh no, this is a 1 by 1 cube, not a 2 by 2. So we just go back 1 and straight up and straight over like that. And to show you that this is a pretty good approximation of what cubes look like, I'm going to swap that out with an actual cube, and you can see that it's really, really close to being the same thing. Not exactly, for reasons we'll talk about later, but really close. If we want to go back further, make a shape that's longer, we just count back. We still need the same orthogonals, but we're just going to count back 3 instead of 1. And that gives us a shape that is 1 by 1 by 3, like that one. If shapes are right in front of us, we can still use them. We can still draw them using one-point perspective, but things get a little tricky because we can't see the grid behind the shape anymore. But we can still find those back corners and go straight up from one of them and figure out where to cut off the shape, like that. There's another one. Now, as soon as the face of the object we're drawing starts to tilt away, so it's no longer parallel to the picture plane, or perpendicular to the line of sight, which is the same thing. Then we're not talking about one-point perspective anymore. Notice that on the floor and on the wall, we're no longer seeing horizontals. We see lines that are starting to angle off in another direction. So obviously you couldn't create a scene like this just doing all the horizontals with your T-square. None of them would actually conform to that direction. And that means it's not one-point perspective anymore. See that? Really not horizontal at all. What we've just created are another set of orthogonals. And these are converging way off to the right and way out there, which would happen to be the same level as our first vanishing point, which also happens to be the same level as the camera, or what we would typically call eye level. And you can guess what this kind of perspective would be called, not one-point perspective, but two-point perspective. Now we're just going to swing back around. And notice we're gradually turning, we're facing the camera again. And that's when we can use one-point perspective. It has nothing to do with what direction you're looking. It has to do with this kind of tricky idea of the picture plane. See, we can leave the picture plane where it is, and we can slide this thing to the left, and we can slide it to the right. But until we start turning like that, we're still one-point perspective. So this is one-point perspective. Still one-point perspective. But if we turn the camera, now this is two-point perspective. And we can leave it right there, but twist things around. Now it's one-point perspective again. You see the difference? Two-point perspective, one-point perspective. And again, you've used T-squares for a while. Obviously, this is a scene here that you could draw using a T-square and a triangle, and this one, not so much. You could still use your triangle for verticals, but there's not a set of horizontal lines. If you're having trouble with this technique, it's useful to shade in your footprint and really think about where your things are hitting the ground. And you can also, if you do heights on one side of a slice, remember what the term slice means, you can use that same height and carry it over anywhere else in the slice like that. So we can build things up that way. But the way I taught you involves using the scrap paper rulers. And if you're still not clear on that concept, notice what's happening here. We're going to take this line segment on the ground that's red right now, and swing it around, and that's how we find one unit in that slice. Notice if we moved that red line forward or backward, it wouldn't work anymore. It would be the wrong size. It's only going to be the right size if we leave it right here, and only if it's right there will it tell us how tall to make this thing. So that's using the scrap paper ruler idea and the footprint idea to create a solid object. If you happen to have gridded a wall, you don't need to use scrap paper because you already know how tall things are up against the wall. And you'll notice that something interesting happened in this drawing, which is this yellow orthogonal in this image is not going down like all the others. It's going up. And that happens when the object is taller than the eye level. So in this case, assuming each of these blocks is, I think they were 3 inches tall, we can see that this object is 9 inches tall, but the eye level is only about 7.5 inches tall. And that just means that we're looking up at the top, which means that in a photograph we can't see it anymore. This is the first shape we've put in that we cannot see the top because it's above eye level. And here's something, the same shape in a different position. Notice that no matter where we put it, we still can't see the top. It's still above eye level. And that's the end of my PowerPoint. Thank you very much.